sixth graders. We're going to take a minute and look through some of the problems from today's class review. Based on the feedback I got from you today, I understand that you wanted to see number 4. I believe you also wanted to see number 6, number 8, and number 10. So we're going to take a look at those together. And this PowerPoint will be available to you on my blog, but it is the PowerPoint that we used in class today. So let's go ahead and get started with number 4. For number 4, the problem reads that 26 is 40% of what number? Let me write that a little neater, sorry. Okay, well, if I want to solve this problem, there are a few ways I can solve this, and I know that some of you are familiar with setting this up as a one-step equation. If you know how to solve this using that method, that is fine, but because this unit we're studying rates, ratios, and percents, I'm going to solve this problem using a bar diagram. And I'm going to start like this. Now, this is a part to whole equals a percent out of 100 ratio. And here we know the part. We know that the part is 26. We don't know what the whole is. Our problem asks us to find it. But I do know that 26 is equal to 40% of whatever my whole is. So let's break up this bar diagram. We can draw a picture to help us solve this problem. The bottom portion of my rectangle is going to represent my percent, and it can go anywhere from 0 all the way up to 100. My top portion of my rectangle is going to stand for my whole. The least amount it can be is 0, and I don't know what the full amount is yet. That's what I'm going to find out. Now we want to divide up these bars into pieces that are sized so that I can land exactly on 40% and exactly on 100%. And I know most of you are going to recognize that I could divide this up so that each piece is worth 20% out of my 100. And I'm going to divide this whole number bar into the same amount of pieces. So let's start. If I divide this into 5 pieces, then down here, each one of those pieces are worth 20%. Because 20 plus 20 plus 20 plus 20 plus 25 times equals 100. Now my problem told me that 40% right here is equal to 26. So I know that 40%, this part right here, is equal to 26. Again, this was told to me in my problem. So this part is equal to 26. So now I want to determine what each of these pieces are worth. So I need to think, what number plus itself? These have to be, all of these pieces are going to be worth the exact same amount. And here we've got 2 pieces that make up 26, so of course each one of those are worth 13. But that means all of them are worth 13. So now if I add together all of these pieces, 13 plus 13 is 26. Another 13 plus 13 will get me to 52, because I know 26 plus 26 is 52. And another 13 will get me to 65. So to answer the question, 26 is 40% of 65. Because again, that whole right here, this whole thing, would be worth 65. That's what that problem looks like. And I'm going to erase that. If you need to pause me, if you want to write this down, if you need to think through it, that's just what this one looks like. Now let's take a look at another problem that you had asked to see, and that is number 6. Number 6 is very similar. Number 6 is a story problem that tells me in the last hour 50 pizza orders have been placed. 60% of those orders are for delivery. How many pizza orders are going to be picked up? Now again, there is more than one way to solve this problem. There is definitely more than one way to solve this problem. I'm going to solve this problem using a bar diagram. If you've got a different way that you would like to solve this problem, you are welcome to do so. Here we've got a part and a whole equals a percent out of 100. Okay, well on this problem, on this problem, I know that my whole is 50. I know that there are 50 orders placed. I know that part of those orders are for delivery, and the rest of them are for pickup. So let's take a look at how that's going to look if we solve it this way. So I drew a rectangle. I divided it into 2 whole rectangles, and my bottom rectangle is going to represent my percent. My top rectangle is going to represent my number, and I know the whole. The whole was given to me. I know there were 50 total orders placed, and I want to find 60% of them. So, and I look here at my fraction, I want to partition this percentage bar into pieces where I will land exactly at 60 and exactly on 100. So I'm going to cut those pieces, or I'm going to cut that percent bar into pieces that are each worth 20% again. That's just a coincidence that it worked out to be the same. But each one of these pieces is worth 20%, and I know that my whole is 50. So if I look at that, that's cut into 5 pieces, isn't it? If this piece plus this piece plus this piece plus this piece plus that piece is equal to 50, I know that each piece is equal to 10. If I add 10 to itself 5 times, I will get 50. Well, I know that 60% of these are going to be delivered. So 20, 40, 60. These pizzas right here are going to get delivered. And as you can see, that is 30 pizzas. Because 10 plus 10 plus 10 is 30. So that leaves these guys here. These pizzas are going to be the ones that are picked up. And 10 plus 10, of course, is 20 pizzas. That's one way of solving that problem, but that is not the only way of solving that problem. You may have taken 50 and multiplied it times 0.6 and gotten to an answer that way. This is one way of representing it visually. If this strategy helps you, use it. If that's not a strategy that you need to use, that's okay too. All right, now let's take a look at number 8. Number 8 is simply a ratio. We're looking to make an equivalent ratio. And number 8 tells me that 1 gallon is equal to or is the same as 3.79 liters. I'm just going to abbreviate that with L. Well, there's 1 gallon for every 3.79 liters. Now I want to know how many liters are equal to 8.5 gallons. So I want 8.5 gallons, and that's equal to a question mark. But in this case, let's just leave it like an empty box so we can fill it in with numbers. Is equal to some amount of liters. Well, now let's think. We need to keep this relationship in proportion to each other. So to go from 1 to 8.5, I needed to multiply, oh, that you can't see that there. To go to 1 from 1 to 8.5, we multiplied by 8.5. Well, in order to keep this ratio in proportion, we have to do the same thing to the bottom. That's math law. We multiplied the top term by 8.5. We need to do the same thing down here. So now I'm just going to go and work it out. 3.79 times 8.5. I'm going to pause the video while I work this out so that it doesn't waste time, but I know you can multiply too. So hold on, in just a second I'll be back with the answer. Okay, so there's the answer. Sorry, I didn't want to waste the video time with the multiplication. But when you multiply these two together, you will get 32 and 215 thousandths. I believe the problem asked you to round it to the nearest hundredth. So that would be 32.22 liters. And there, that ratio shows that 8.5 gallons is equal to 32.22 liters. Okay. Now for the last problem, number 10. Number 10 reads that the Spider Scrambler ride at the fair has a cart at the end of each arm that holds 3 people. Now this is a very long problem, so let's start just by drawing a picture. Here's my spider. At the end of each arm, there's a cart. Now your picture might look a little bit different than mine, and that's totally fine. But drawing a picture sometimes is a great way to make sense of a long problem, and this is a long problem. And it tells you here, or as you can see here, each one of those little carts holds 3 people. Now every time this thing takes people for a ride, including loading and unloading the passengers, it takes 7 minutes. So let's start by setting up a ratio table. Here, let's take a look at the number of passengers. And here, let's take a look at the time that has passed. Now, I'm going to include another little thing up here, and this is just going to show the turns. And that's just sort of so I can keep track of this as well. So every time this thing takes a turn, 24 people get to go, because each one of those 8 arms holds 3 people, and 8 times 3 is 24. And it will take those people 7 minutes. That was my first turn. Now, I'm just going to draw in some lines because I know that this is going to be a long ratio table. That's showing 1 turn. Here's my second, and my third, and my fourth, my fifth, and my sixth, and my seventh, and my eighth. I may need to even add to that as we get further, but this is just showing me how many turns it will take. Because I'm trying to figure out if everybody in line is going to be able to ride this. Now, I need to pause the video again because I'm running out of time, but I am going to fill this in. So every time we take a new turn, it adds 7 minutes onto the total, and that means 24 more people get to go. So I'm going to pause this and fill in the ratio table. See you in a sec. Okay, kiddos. So you may want to pause me for a second and fill in your ratio table if it helps you. You'll see I noted, or I added over here, that there are 178 people waiting in line. And I am trying to see if everybody waiting in line is going to get to ride on this ride. Now I know the fair closes in 1 hour. The closest I can get to 1 hour without going over is right here at 56 minutes. This time right here is shown in minutes. Because if I add 7 more minutes to that turn, I'll be at 63. If I go for a 9th turn, that'll take 63 minutes, and the fair will be closed by then. So if you take a look at the ratio table, I know for every turn, or every time they load this ride, 24 people get to go, and the ride will take 7 minutes. So this ratio table here shows that after the 2nd turn, 14 minutes will have passed, but 48 people will have gone. So as you can see, yes, all 178 people will get on the ride.